x doesn't repeat, which means that it is a function because the x will not be repeating. So that is a function. This is how you can see if it's a function or not a function. So now let's talk about what it means to be a one-to-one function. One-to-one function. So let's talk about this. So the little definition that I'm going to give you so that you can remember if it is a one-to-one function or not is simply that it has to pass the vertical and horizontal test. So it has to pass the vertical and horizontal test in order for it to be a one-to-one function. So let me give you an example with the graph. Because in order for you to know if it's a one-to-one function, you have to graph them. So let's look at this graph that I'm about to draw here. Let's say we had the little function like so. Well, the vertical test is when the lines go up and down, and it means that it only touches one point. Well, yeah, it's only touching one point, right? Only touching one point, so it passes the vertical test. I'm going to represent vertical with a V. Passes the vertical test. Now, horizontal. Well, yeah, once again, it's only touching one little point. So it passes the horizontal test. So this one is a one-to-one function. It is a one-to-one function. It is because it passed both vertical and horizontal tests by only touching one point. But let's say we had a different type of function, and when we graphed that function, it gave us something like so. Well, in order to see if it's a one-to-one function, it has to pass the vertical and horizontal test, right? So let's do the vertical test first. Well, yeah, look, it's just touching one point. So it passed the vertical test. Now let's do horizontal test. Oh, it's touching 2 points. It's touching 2 points, so it did not pass the horizontal test. It did not pass the horizontal, so this one is not a one-to-one function because it didn't pass the horizontal test. So remember, for it to be a one-to-one function, it has to pass the vertical and horizontal test, as in the first example, where it only touches 1 point for each test. This second example was wrong because it didn't touch only 1 point. It touched 2 points for the horizontal test. So even though the vertical test was correct, was passed, the horizontal was not. So they both have to be passed in order for it to be a one-to-one function. If not, it will not be a one-to-one function. Now let's talk about an inverse function. What is an inverse function? So, an inverse function basically reverses a function. It basically reverses a function. or in other words, it mirrors its function. So let's use an example of x cubed. When we find the inverse of x cubed, which was explained on how to find inverse in one of the previous problems, which are the steps: you first change f of x into y, then you flip x and y, you interchange them, and then you solve for y. Well, once we solved for y here and we get the inverse of it, we get that this is the inverse. So you get the idea, right, on how to get the inverse. Well, you also remember that in order for it to be its inverse, we have to check graphically. We know that this is a little mirror where it equals x. We know that that has to be the mirror. So then when you graph this one, you see that x cubed would be something like this. And that this one would be something like this. And I know it might be hard to see the difference, but you do see that when we draw the line in the middle, slightly in the middle, I drew mine a little bit crooked, but look, if we draw it exactly in the middle, we see that it is mirrored on both sides. So that's how we get our inverse function. We see that it mirrors it on both sides. And now to explain log and exponential, and how are they related? Well, we're about to find out. The only way to see how they are related is by graphing them so that we can see how their graphs look like, and that way we can see what their relation is. So if we were to graph log, this one would have been log. If we were to graph the exponential function, this one would have been ex, the exponential function. And oh, what do we see? They are what? We see that they are inversely related. They are inversely related because when we graphed them, we saw that log has this graph and that exponential has that graph. And we got that they were inversely related because we mirrored it, and that's how we got to see that log and exponential are inversely related. And we know this is right because inverse reverses a function and it mirrors the function. So as in this example, the function was mirrored with x cubed and 3 to the square root of x. It was mirrored, so it was inversely related, and so is log exponential. Because of the way that it's graphed, we can see that they are inversely related. So that is the relationship between log and exponential function. They are inversely related. An inverse function mirrors the function. A one-to-one function has to pass both vertical and horizontal tests for it to be a one-to-one function. And a function does not repeat its x. It does not repeat its x. So that's what we basically talked about. 'Cause you're